when we learned how to graph quadratics, we learned that there were basically three forms of a quadratic function that we had. We had standard form, we had vertex form, and we had intercept form. Now, to go from standard form to either one of the other two forms, we have to go through a process of simplifying. And the first process to go from standard form to intercept form is basically using the factoring method. And so sometimes the intercept form is called the factored form. For vertex form, however, we're going to go through this process called completing a square. It's a little bit more complex. So what we're going to show you how to do here is to take the standard form of a quadratic equation and use the completing the square process so that we can make this in an easier form to graph. So if we look at example 3, y equals x squared minus 8x plus 11, we can't factor that, so we're going to use the quadratic, we're going to use the completing the square process. So you can see here we're going to actually kind of group, in the second step, we're going to kind of group x squared minus 8x kind of by itself and kind of shove the 11 to the side. Now, when we complete the square with the 16, it's important that we add that to both sides to balance this out. And then once we get the perfect square trinomial, we can move the 16 back over so that y is by itself. So you can see here that the vertex form is y equals x minus 4 squared minus 5. Now you could also see that in the form of f of x, because f of x and y mean the same thing. So go ahead and see if you can continue to use this completing the square process. We have two quadratic functions for you to complete the square and change the vertex form here. Okay, so the first thing I want to really do is I want to just kind of group these off. I want to complete the square for x squared plus 6x. And so in doing that, I'm going to end up adding 9 to both sides here. So I'm going to have x squared plus 6x plus 9, and I want those kind of grouped away from the 16. And then when I do that, I'm going to create a perfect square trinomial. So I have y plus 9 equals x plus 3 squared plus 16. And to get this in vertex form, I have to basically get the y by itself. So I'm going to subtract 9 from both sides, leaving me 7 on that side. So y equals x plus 3 squared plus 7. And if you recall from graphing quadratic functions in vertex form, this vertex would be negative 3 and a positive 7. So if you needed to do that, you could go that route. Now, for part B, I'd actually like to show you something just a little bit different. What if we had given this to you as f of x? Sometimes it doesn't look so great for us to add something to both sides. And so if I want to use this completing the square process without adding a value to the left side, I can still keep my equation balanced. And let's look how we do that. I'm going to group off this x squared minus 2x. And so in this case, I need to simply add a 1 to create a perfect squared trinomial. However, if I've added 1 to the right side and I haven't added it to the left side to keep it balanced, I need to somehow balance this right side out. And so the way that I can do that is I can actually subtract a 1 as well. And so subtracting 1 and adding 1 to the same side of the equation has the net effect of 0, and so I have not changed the value of the function. So I can continue along this route and say that f of x equals x minus 1 squared minus 5, and this is also vertex form. So just another way of looking at that, just in case you run into a problem like that in the future. Okay.